Teddy Baldessar and Britt Pierce got invited to visit Breitling's facilities a while ago. Why didn't I get invited? I mean, I could understand if it was Patek, because I may on occasion have said something wildly critical about Thierry Stern. But George, what did I do? I've only spoken positively about you and your brand. Even in a recent video, I even called you a great CEO. Is it the hair? Are you feeling threatened? Is that what it's about? Well, you're not going to be able to hold me back from talking about your production anyway. I'm taking Teddy's video and I'm going to watch it and I'm going to reveal the secrets that Teddy didn't showcase. I'm going to expose the truth about that little visit. What's in-house, what's not, what you're good at, and what's relatively run-of-the-mill. And I'll talk about what wasn't said. I'm going to give my viewers some context to those videos. So let's dive in. But first, a scene change. And here we are in my editing studio. This is where the magic happens, where I actually put together the final videos after I've filmed them in my stunning state-of-the-art studio, MKBHD style. The reason we're in the editing studio right now is because I'm going to be watching the video at the same time, so I can stop and pause and I can comment as I go along, so it's so much easier for me. I'll put the clips in as we go, and let's dive in.
Here we are in Le Chaux-de-Fonds, an industrial hub for Swiss watchmaking. This town, located in the canton of Neuchâtel, has been home to some of the most celebrated names in horology.
This is true. I've been there a couple of times now. You drive down the road and you just see Cartier, you see Patek, you see Breitling, you see also the sub-suppliers, so Sellita and AMT and Bergeon and all sorts. There's a ton of companies in this area, and just over the border in France there's also a couple of watchmakers, so this is like watchmakers central.
So here in this specific workshop, we are in the technical office, mostly for development of movement. And everything starts from here to do the first construction, conception, simulation, and then we can start with already a very good base for the prototyping.
Yeah, this is what everybody does. If you're making movements, you have a CAD program of some sort, and you are from the base designing your movement and every single individual component. So it's not just a 3D render, it is an accurate to the millimeter 3D render where they simulate how the movement would work. And at some point they will split it apart into individual components, and that's what turns into the specifications that you produce according to.
So when you're developing something like this, like what is the thought process? Where does it start? How long does this take?
So the question is, how long does it take? It takes a long time. He doesn't really answer the question. But what he's saying is we use the B01 movement. Why do you use the B01 movement? Because building on top of an existing movement or building a module is more efficient than starting completely from scratch. If you want to start completely from scratch and conceptualize a movement with, essentially a black piece of paper, it's just going to take longer than if you take an existing movement and say, how do we want to make changes to this to optimize it? And in a company like this, you're going to be thinking not only about, coming up with a super cool movement, but you want to reuse and you want to re-implement already thought out ideas, so you're not sort of reinventing the wheel every single time you come with a new movement.
And when you're manufacturing like a component like this whole perpetual module, is this something that you're doing and producing in-house? Like when you're designing this and then also developing it, like are you doing the prototyping right in this workshop as well and all that?
Some of the elements are done internally.
Are you doing it all in-house in terms of prototyping? The clear answer is some of it is done in-house, so they are definitely asking external providers to do pieces of this. The actual design of the movement, the CAD-CAM, that's them, and the split out and say these are the things we need. But then they also have some things that say this is technically too difficult for us. We can't do this one thing, a bridge or a lever or an arm or whatever. And then they will call somebody and say, hey, can you guys help us with this specific thing? You're experts in this material or this thingamabob, and we need it for this and this movement. It has these specifications. Can you do this for us? So already here we're hearing how it's a collaboration, not fully in-house in the sort of romanticized example of it, but a collaboration with external suppliers.
But again, what is for me is the most important is the conceptions, because we are not talking only about the functions, we are really talking about at the same time the reliability of the movement. Of course, the price, the cost, it's also a very element, so we have to think a little bit how we will produce or we will assemble the movement.
important thing he's saying here. It's not just about having a cool movement. There's the conceptualizing and the design and the beauty of whatever movement and how it's going to look for the end consumer. But he's also thinking about how difficult and how expensive is this to produce. So you can have a watchmaker who's like, this is super, super cool. He's going to be like, dude, this is going to cost way too much money to produce. You need to find a simpler way to achieve the exact same thing. And there's always a back and forth in this. And they're producing 200,000 watches or however many a year, 150,000. And they need to be able to produce at scale. So some finicky little thing that looks super cool is super impressive, but is going to be massively expensive. It's just not going to get through the approvals process.
And even more important is then also the repairability, being able.
Repairability. That's also a thing. We make something that looks super, super cool, and then he's thinking, okay, what's this going to cost us in terms of repairs when the customers come back? Not that it's going to be a bad quality, but there are things that break over time, and if you need specialized parts, specialized components, and you're not using standardized parts and standardized components, and it's difficult to disassemble, it's difficult to put back together again, it's going to add on the cost. And typically within the first 2 years, all sort of repairs are very much the company's problem. So you want to make sure it's something that's repeatable and, relatively speaking, cheaper to do, and not something that's super, super complicated.
Today here we are in the laboratory who support the movement development as well the production. When we have, I would say, an issue or something, we can make all the tests and analysis.
So this room is for movement development and testing. This is not testing of finished mass scale, mass production movements. This is where they've got the idea, they've conceptualized something, and they're going through the paces of actually building some prototypes and testing every single part and figuring out whether or not it works, and ironing out also the production processes and saying, we need to change this, we need to change the materials in this way so it works.
Next step we want to see is the aging test. Here what we can see is a test of the pusher, and we are doing aging who simulate 16 years.
So how long are these tests going to simulate 16 years?
So for this specific one, it takes 3 days.
This is what you pay for. You pay for somebody that's prototyped a movement and they have put it in, and this is just costing them money. This is 3 days where they're not producing anything. They are just testing this movement constantly over a period of time to simulate 16 years worth of wear. This is one of the things that's underappreciated in the context of watchmaking. The amount of time that goes into quality control, the amount of time that goes into testing. The cheaper a watch is, when you're buying something from Sellita, obviously Sellita has tested their movements, but if you're getting that into some whatever watch from some other watchmaker or sort of brand, they're not doing these things. They're just casing it up, doing a minimal of testing. And what you're paying for, the higher up you go in price, is more of that testing becomes standard, where a lot of that testing just doesn't exist at the lower end because it's so cost intensive. Some of that they don't have to do because they didn't develop the movement. But there's a lot of money that goes into the testing, which at the end leads to a more reliable and more precise and more accurate product.
We have seen simulation, we have talked about theory, but now we have the real life, and we have here exactly what a watch must resist. And here we simulate if we let the watch go.
Okay, this is hilarious. It's a hammer. A guy holds the hammer, it swings down, hits the head, and it's checking your impact. And it's a typical test in a lot of manufacturing of physical products. But, this is where Switzerland is Switzerland. It's not quite as high tech as Samsung or iPhone or those kind of companies.
That is drop testing. And it turns out Apple has been doing their own internal drop testing for years now. And then they can have it repeat that exact motion and that exact same drop on the exact same angle over and over again, but with different surfaces, and they can A/B test them and take a look at exactly what happens.
Should I do it?
Please.
All right. I love how we have all these complex machines, but then in a good old swinging hammer.
And we do that for every new watches that we develop and bring to the market.
What we have here is component development, and the machine you can see is a CNC machine, and my guess it is a 5-axis machine. And when we talk about axes, essentially a machine that can turn and cut from different angles, either by manipulating the thing that it's cutting or by moving up and below. And the reason you like multiple axis CNC machines is if you have a 2-axis machine, then you have to put the thing in, it'll cut, and then you have to open the machine up, you have to stop the machine, then you have to move the thing that you're cutting, put it in a new position, close the machine, start all over again. So the more axes, all things being equal, it's more efficient.
Okay, Teddy, we are now in the micromechanics workshop. We have support for movement development, but also for watch and habillage development.
The also thing that's interesting here, and you just look, there are no people. This is manufacturing. You don't need a lot of people to do this. It's the machines that are mainly doing the work. Later on, when you get to the assembly part, you'll see more people. But right now, and for quite a while in this video, my guess is you're going to see very, very few people.
At the same time, we have also production of some movement components. Here we have our 2 CNC 5-axis on which we are doing cases, case back, bezel, crown, pusher, this kind of things.
There are already so many interesting things to this video. There's 2 things that I think I want to call out in this context. The first one is what he says. This CNC machine is used to make cases, crowns, and bezels. What doesn't he say? Doesn't make bracelets. So he hasn't shown a machine that makes bracelets. It doesn't surprise me. My guess is, and I'm going to make an assumption, there's probably somebody else doing the bracelets for them. The other thing he's saying is they have 2 CNC machines. And just the simple math of it, if they are putting out 150,000, 200,000 watches potentially a year, I think that's round about the numbers for Breitling. 2 CNC machines, and they can, in theory, run 24 hours a day if you want them to. They are not 24 hours a day, 2 machines putting out 200,000 cases, 200,000 bracelets, 200,000 crowns, and 200,000 bezels. That's just not the case. So either they have a manufacturing facility somewhere else, which is doing the bulk of the manufacturing of these 2 machines. I don't think that's the case. They are probably doing the base sort of prototyping of cases and say, this is what we need, and then they are speccing it, and then they're sending to somebody else to say this is what we need for a case, for a bezel, for a bracelet, potentially. I'm briefly back in my real studio. Just because I'm doing a reaction video about Teddy and Breitling doesn't mean I won't be plugging for a subscription. Subscriptions tell me if I'm doing a good job much more than views. So if you're new here and you aren't a subscriber, then consider subscribing. It's really appreciated. And while you're at it, if there's something you want me to talk about or give me some feedback, leave a comment. I read all of the comments. Thanks a ton. And now, back to the video.
To support the production. For example, we have
those little square brass plates are important. You're going to see them everywhere in this video from now on. They are a totally standardized thing. What you're seeing on top of them is the rubies. They're not rubies, they're synthetic jewels, and they're the ones that basically don't lubricate, but they reduce friction. They've used, you hear it's like a 24, 23, or 26 joules. But these plates are basically used for making base plates. They are used for making all the components, the bridges, tons of things. They are super, super standardized. Every single movement manufacturer uses these plates. They are the same size. They are the same thickness wherever you go. The holes that you see around them on the edges and sort of the indentations, they are there so machines can hold onto them when they are busy machining something on them.
And here you can see some sample of different components that we are doing here. This is more for component for movement.
Here you see those plates again, those standardized plates. In this particular one, you can see that it's been used to make 6 individual components in one plate.
If we have enough space, we put.
And the next one has 4 individual components that have not been removed from the plate yet, but have been cut out in the actual base plate.
Why do you decide to still want to develop components in-house and do this?
Here in particular, it's to make the process of development more quick. It's time to market. Because if we are able, we do the simulation.
Yeah, so this is very straightforward. If you're prototyping something, you can do 2 things. You can do the CAD-CAM thing and split apart the components, and then you can send that specification to a supplier. That supplier is like, okay, I can get this done for you in 2 weeks' time. I have a build slot for you there. Then they do it there. Then they'll send the stuff back to you. Then you look at it, you test it, and you think it lives up to the expectations. If not, then you have to give them a call. You send it back again. You do a new try, and it's like 2, 3, 4, 5, 6, 7 weeks, whatever. It takes a whole lot of time, this back and forth between suppliers. So instead, you bring it in-house, and that means you take from the computer, you go straight to the milling machine, it mills whatever you need to mill, then you can do the assessments. Did it work, did it not work? You go straight back next door to the guy sitting at the machine, say you need to make this adjustment because it's making this mistake, and you can almost instantaneously get it done. It saves you a bucket load of time and you get a lot more control.
So Daniel, is there a specific component or like components that you're really thoughtful of wanting to maintain the know-how?
The balance wheel.
So you can actually still produce those here. Like you don't
Yes,
have to rely on
exactly.
suppliers if you don't need to.
For us, it's strategic to have this know-how, to conserve it, and we are still producing every day a certain number of our balance wheel. Of course, it's absolutely not the entire productions because we need much more than that, but it's important to keep and to conserve the know-how internally.
The question Teddy asked was, is there anything in the component production that they prefer to keep control of or keep more, so to speak, in-house? And one of the things the production COO guy says is the balance wheel. And first, to talk about why would you want some things more in-house than others? And he says it's important because they want to keep the know-how, and that's essentially the key. This stuff that comes to watchmaking that's not particularly hard and is not particularly important in terms of sort of knowledge, right? A cog or a wheel or anything with teeth is not necessarily the most important thing in the world. Anybody can produce it. You put 56 teeth or 26 teeth. It's a standardizable process. It doesn't make a huge amount of difference as long as you're building the component to the right specifications. But if you've looked at enough movements, you'll know that balance wheels look very different and they have a massive impact on power release, friction, amplitudes. The core functionality of the watch is hugely impacted on the mainspring, the balance wheel, the barrel. Obviously, there's friction in between, but those are like big ones. And that's why they're saying, okay, we want to keep that knowledge in-house. That makes sense. The other thing he's saying is he's not saying they're producing all of them. What he's saying is they have the know-how, they build them, and he's at least not explicitly saying that they do them all themselves. He's indicating kind of that they do a certain amount themselves, and then they send out the specs to somebody else and say, continue to do that. I would assume in some companies, more high-end, where they have very, very proprietary, call them balance wheels with more complexity than the one they're showing on the picture here, that these would be made fully in-house because it's one of the places that differentiates a really good watch from a random watch. And having that knowledge and protecting that knowledge a little bit is part of what makes some brands special. But in the production context, they're probably not making all of these for production in mass numbers themselves.
And again, it's very useful when we are doing prototyping for new.
Yeah, he says again, it's very useful for prototyping. This is not for mass production. This is just for their prototypes. And once they've got the process down, then they can specify it and send it to a supplier. Say, you need to do it to these qualities with this kind of machine, with these kind of tools, at these speeds, etc., etc., etc. And then they can get exactly what they want.
Okay, now we are entering at the beginning of the production of the movement. So we are working.
Again, what do you notice? There's one person and a bucket load or a room full of machines. This is not a human-intensive process. These are machines that are doing most of the work, at least so far. You'll see people later on. But here, it's just machine by machine by machine. And these machines, as far as I can tell, are the ones that are going to be machining those plates, and they're essentially moving from one machine to the next, to the next, to the next, to the next on a conveyor belt. What you see here is one of the machines that mills these plates for base plates and components that go into the movement. There are multiple of them. What you see in the middle is this little round thing with these little spiky things all around. Those are the tools. So the machine takes in, it grabs a tool, cuts, puts the tool back, takes another tool, cuts, does whatever it needs to do, and does whatever part of the process this machine has, and then it moves it on.
Where we are doing at the same time the main plate, but also all the other bridges. There is 4 big steps. The first one is the milling itself, and then we will move to do the sandblasting. This is an operation that we start to remove a little bit the
debris on the component.
Yes, and also all the mark of milling. And then we continue also with treatment of deburring with water high pressure jet.
Okay, what he's saying is there's essentially a couple of steps. The first part is the cutting, the milling of, the shapes and all the sort of indentations that you need. Then it moves on to the sandblasting piece, which blasts essentially all impurities, all irregularities, so you get a uniform flat surface. And then they do a second step, which is with water, which is the exact same thing, well, not exact same, but he calls it deburring, which is deburring. So anytime you've either done woodworking or with metal, you get little burrs that sort of stick up anywhere, and the water is just essentially there to blow that away, so you get a completely flat and uniform surface that you can work with.
And here, of course, we are always talking about the quality of the movement, quality of the component. But for us, what is also very important is to be able to produce efficiently.
Quality and efficiency. Quality is, in this sense, for watchmaking, it's all about flatness and it's all about precision of the depths. So it's the angles and making sure it's got the precise depth that you need. Because anywhere where you have inconsistencies, you're going to add friction, you're going to add something that can hinder the path or the movement of the energy through the gear train. And that's why you want highest possible quality in terms of all those little micro adjustments. There's probably a testing phase later on. On top of that, then he says efficiency. Those machines, they're just really, really fast. The reason they have them on a conveyor belt is, if you look at simple supply chain or logistics logics, if you get one machine to do 15 things, it's going to be slower, because every time you have to get a machine to change its mind or change a tool, it's going to slow down. So it's better to have a machine do a few simple tasks, potentially even one, and then you move on to the next, and they'll do another thing. So you'll have one machine just drilling holes, drill holes, drill holes, drill holes, and then move on to the next one. It will mill a indentation for a gear. And then it'll move on to the next one, it'll do another piece, and it'll do another piece, and it'll do another piece. And that's the way you get the most efficient production. It just massively works on scale if you can keep the machines doing the same thing basically all day long without intervention and just moving from a conveyor belt. So there's no people that have to take it out and put it in, take it out and put it in. It just moves automatically straight through the process. And as long as the machine's working, no hands need to touch it.
That we're talking about on this scale.
Absolutely, here we are talking about 8 components.
What you're seeing here are the individual components that have been cut out of the plate and are now separated.
Absolutely.
There's a lot going on for the programming of that.
No, this is definitely.
If those of you have noticed, everything is brass right now and yellow, and all movements, usually they look silver or steel colored, and that's because they are galvanized. They start out, all of them, pretty much, unless it's German silver, in this color.
And the precision must be really extreme, I will say. As soon as we have...
Yeah, precision, that's the key. Everything in terms of movements is precision. Even the base plate, the flatness of it, the depths of the indentations, everything needs to be spot on, because anything that could hinder the movement of the gears and trains, that's going to make the accuracy and the reliability of the watch worse.
The quality of those components must be perfect. That's why we have had, a few years ago, new equipment they can do
automated testing. Instead of having individuals looking at the individual plate and hoping they can see whether or not there are imperfections or indentations or something that's not supposed to be there, you put it in a machine and you can do it much faster, much more precisely, down to essentially the micron, and it'll measure at selected points. There's a path you can see on the screen where it goes from around the essential component and say it's supposed to be this deep here, it's supposed to be this wide here, etc., etc., etc. And this is just, again, to achieve that level of accuracy and essentially quality or perfection that they're looking for, so it can actually perform the way they want it to.
Control, both for dimension, also for the position of all the holes that we have. And thanks to this automatic new control equipment, we have been able to
I think this is really important to emphasize, because a lot of people think you make a movement and then you put it all together and then you sort of case it and then off you go. One of the things that adds cost, and one of the things that you would expect a company that sells a $5 or $6 or $7 or $8,000 watch, and not from a $1,000 watch, is that they are doing these steps, these automated testing steps. So they've tested in the prototyping phase, they've done all sorts of tests there to see it works. Then they get to the manufacturing phase, they test it there and they do all sorts of tests there. And later on, you're going to see they're going to test again. And these are all sort of steps that don't do anything different to the movement or the case or the component, but this is time that they spend to make sure it's up to the quality that you want. That's what you're paying for, in part, for those higher end movements and higher end watch components.
So Daniel, as we proceed through this concept of assembly.
Now we're in pre-assembly. And what is pre-assembly? Well, it's what goes before assembly. But think of Lego. You've got one piece of the Lego that you build. You've got the other piece of the Lego that you build. That's the pre-assembly. When you take those two pieces and put them together, that's assembly. And that's essentially the way it works. The other thing you need to notice, finally, they're people. Now you can actually see people. And maybe you could call them watchmakers. I think they're probably going to call them assistants or operators, because what they do is very standardized. It's very monotonous. It's the same thing they do all day long. It's pretty repetitive.
You have human touch, and then you have automation that can happen depending on what needed to be done, correct?
Yes.
Producing and assembling things that have been either produced internally or purchased. Again, they're buying stuff from the outside.
But when it's become more complex, and here we are talking about the garnissage, the word in French, where we put the rubies, the small pins on the main plate or on bridges, here we are usually using more automatized equipment.
Makes sense. Basically, anything you can get a machine to do is probably going to be faster. And taking those individual synthetic rubies and putting them on, you'll have a person sitting there one more back and one forth, back, forth, back, forth, back, forth. Get a machine to do it. It's a standardizable process. It's going to do it a whole lot faster. It's going to do it right more often than not. It's also better for worker health and safety because it's kind of repetitive. You're going to have pain in your hand if you do that. You know, if you've got 26 joules for 200,000 watches a year or however many they're making, that's a lot of repetitions of moving those joules back and forth and the little pins and all that kind of stuff.
No, with new equipment, we are both kind of equipment, we can have even better level of quality and repeatability.
In terms of setting these machines too, because it's automated.
There's no romance to all this watchmaking. This is mass production and mass manufacturing. Everything he's talking about is when is it automated and when is it handmade, or has it got hands involved? And the key question, you can hear it in everything he says, it's who does it better, faster, and more accurately. And if the computer or the machine can do it faster and more accurately, then they're going to give it to the machine. And in most cases, in a lot of cases, it's going to be the case, especially for the simplifiable process. So picking up that little joule and putting in the joule, and picking up a joule and putting in a joule. That machine is always going to be faster, more accurate, and just better, more precise than a human being. But when you've got slightly more complicated things where the machine can't do it as well because it's too intricate, or it requires, manipulation that the machine can't do, or because it's such small numbers that's setting up the machine, and they're going to get to that in a second, my guess is too slow relative to the numbers they're doing, then it's easier to give to a human. That slows down the process, but it's a balance. He's constantly thinking in terms of cost and in terms of speed, not in terms of romance and handmaidedness. That's not a business perspective for him. It's all about what is the most efficient, best quality way to do these things. If I can get a machine to do it, that's what I'm going to do.
How long does it take to actually set these machines?
When we perfectly master the equipment, anyway, it will take minimum 3 hours to set. But at the same time, if we go to the other automatized equipment, the time of setting will be even doubled. Here we arrive.
Yeah, so like he says, it takes 3 hours or even double to set a machine. The machine isn't just magically going to do. You have to set up the program, say what does it have to do. Then you have to put in all the things that it's going to need. So the joules or the components, you have to set them up correctly. You have to go through some specific steps to test that the machine's working. Because what you don't want is to click on and it does everything wrong and it damages a whole lot of components. That's a waste of money. And then you have to reset and then you have to start all over. Downtime in any production environment is bad for business. You want this to get it right the first time. You want the machine running for as long as possible, and you want as little downtime as possible. The only time the machine should be down is if you're setting it up for a new process. So they're not going to change the machine every day. You might have 3, 4, 5 days in a row where it's essentially doing the same movement, and then after a week, then they might switch to a different movement or a different process. Because you don't want to switch every 3 hours. It's like, now I'm going to do a couple of these and a couple of those. That's just too expensive and too slow. And then the other time it's down is when you're repairing it, you're making service intervals and making sure that the machine is functioning the way you want it to, so it's not creating errors that cause damage to the things that you're building.
So what we're seeing here is just this testing of once that hairspring is set, the balance wheel is...
This is cool. just for the simple fact that they've got so much that's automated and they're doing all this testing. But when it comes to the balance wheel, what's the best, most technologically advanced way to check that it's working the way it is? You've got a person sitting with a magnifying glass and pushing it and seeing if it rotates correctly and it has any wobble to it. This is old school. They haven't found a way to automate that, but that's cool.
One key element is the fact to double check that it's completely flat.
Flatness, stability. You don't want wobble. This is one of the most important parts of the watch movement, that little balance wheel. I'm not going to say it's make or break, but if that isn't working the way it's supposed to, then you're going to have a worse watch.
All the components, whether you're producing them, you're getting them from suppliers, testing them for ensuring that they are going to actually operate within your standard when you get into the watchmaker's hands feature, correct?
Just pay attention when you're working with suppliers. I know I'm kind of beating a dead horse by now, but there's stuff that comes from other people.
We need also different type of equipment. First, good examples is this automatic barometer, meaning that on this specific equipment, we are checking all the barrel.
So this machine checks all the barrels. The barrels are the ones that hold the mainspring. That's the one that releases the power. It's the one that defines what your power reserve is. It the one defines what your torque is and what the torque curve is. And that machine is essentially testing all those kind of things. So is it going to give you the power reserve that you've been promised? Is it going to release the power in the specifications and towards the specifications that are expected? Is it going to have the torque it needs to have? All those kind of things they're testing.
And we can see also different because here we are passing through 100% of the production, huge volume, and here
they're testing 100% of the barrels. That's not uncommon. If you are assembling your movements yourself, that would be a great idea. Again, if you're making a in-house movement in a cheaper brand, you might not be checking every single barrel. You might just be getting the barrel from whoever you get it from and then just throwing it in and hoping it lives up to specifications because you can't afford that big old machine. But at their level, that's why you're paying more for a Breitling or an IWC or a Rolex. They are testing every single barrel. That's not going to happen if you're paying for a $1,200 or $1,500 in-house designed movement where they bought the barrel externally. Obviously, if you're getting it from Sellita, where it's a complete movement including barrel, you would assume that Sellita have tested the barrel as part of that work that goes into the making of the SW210.
And then when it's come for more complex component, and here, for example, we have the main plate. Here we have sent to a supplier for all the decoration and the treatment, surface treatment.
Aha! Like I insinuated a little bit earlier, they don't do the finishing of the movements themselves. They send it out to an external supplier. What you saw earlier in the video was that base plate, which had a brass color, and you saw also the one where you held it in the hand where it had sort of a matted surface, like a PVD kind of surface. From there, that movement has to be galvanized. It's clear that that galvanization process is being done by somebody else. That's what he's saying here. So they send it out and then somebody else gets the brass component and they make it silver or steel in color, which you know from all movements. They have their color underneath. It's brass colored. Then on top of that, they also have somebody externally doing the decoration. So the anglage and the perlage and all those little shiny sun rays and circular things and stuff. That part of that's also machined and part of it's hand done. I would think in the less complicated movements, most of the stuff is done by hand, not hand, but by machine. But the fact is, they're not doing that. So once they've made those movements that they need in the sort of brass base specification, then they leave the building and they go off to somebody externally who's then going to apply the finish and do the actual finishing of the movement. And then it comes back and then Breitling tests what comes back from those people, but they are not doing the finishing.
And when it comes back, we redo all the dimensional control, but in 3D to really verify there is no deformation or...
Again, how important is quality control and quality assurance? They were checking earlier in the process the individual base plates for the depths with the 3D automated machine that was checking. They basically do that again. So twice already for the same components, they are checking to make sure that nothing has changed after the galvanization, after the finishing process.
Yes, absolutely. And we define for every component because the complexity, it's not the same. Mm-hmm. And we have a specific protocol for every component. And we have a ratio between a number of productions, the numbers that must be controlled.
So what he's saying here is there's a difference to what gets tested how much. And as an example, he said earlier, 100% of all the barrels that go into Breitling movements are getting tested. This is because the barrel is so important that they've basically made the decision that every single barrel needs to be perfect, and that's why they check every single barrel. They're probably doing that for the balance wheel as well, and the springs on the balance wheel. Those are probably things that are getting tested individually. But there are other things that they test at a ratio. So they'll test 10% or 1% or 5%. And that's basically based on history and experience. What kind of error rates do they have? This is perfectly normal for pretty much any production situation to have these kind of ratios. So if you're working in a meal kit company, so you get your food from HelloFresh or whatever, then what you're going to see is you get a box and there's tomatoes inside. There's not somebody that has checked every single tomato. And they're sending out, I don't know, 50,000, 500,000, 1 million tomatoes a week. What they're checking is they get from a supplier a ton of tomatoes, and then they check a number of tomatoes and a number of pallets, and they check how many errors are there. And if the errors are above a certain point, then they either check some more to see if it's living up to their quality standards. If it's above that rate, then they reject the entire basic shipment. So you get 500,000 tomatoes, they check 500 tomatoes. If 5% of those 500 tomatoes are bad, then they assume that all 500,000 are bad. That's basically what they're doing here. They get 10,000 base plates back. They check 100 of them. If 5 of those have errors, then they're going to send all the base plates back.
So finally, we are at the assembly stage for the movement. And here we have very specific assembly automatic line. Everything starts here.
So you basically
Conveyor belts, everything's about efficiency. It's not romance, it's conveyor belts.
you'll go on this conveyor belt, and then you have all these stations. So these stations are developed based off of different steps.
So those people working there, they are watchmakers, but this is probably a less complex line because this is very standardized. This is probably not the most exciting job in the world. Hopefully these people are looking to get promoted to take on more responsibility, because essentially what happens, they are sitting all day, a movement goes in, it goes up, they do a thing, it turns around, you do another thing, then you click the button and then it sends it on, a new movement comes in and you do the exact same thing. And you do that every single day. This is not anything other than a production line, just like you see from Foxconn with the people with the mask putting together the components and the PCB boards for an Apple iPhone. It's the same principle, just for watch movements.
And here, as an example, you have 10 vessels that will turn. Here at this station, it's 9 times because we have 9 specific operations.
And then the setup, if you look at a top-down view of this.
2 things here that are fun to me to say. One, he says 9 times, so that's essentially what they're doing. These people are doing the same 9 things for 8 hours a day. Oh my God. But they love what they're doing. But essentially, it's a very repetitive, very straightforward process. The other thing you can see is they're sitting really, really low. These benches are super standardized everywhere in watchmaking. And why? Well, it's because it's better for your neck and your shoulders. It's a health and safety thing. So you're essentially sitting closer to the thing. So you're not sitting as hunched over. These people are sitting a little bit more hunched over than I would like. But that is essentially just to make it more comfortable when you're looking at teeny tiny things and looking through a magnifying glass. You want to be at eye level and you don't want to be looking far up, down and leaning over, because that's going to hurt you.
What are you looking at when you're setting up these stations? Like, what are some of the other considerations on that front?
So at the end, what is important, it's how much time it takes for a certain of operations that we have designed for the bench.
What does he say? What's the most important thing? How much time does it take? Everything is about efficiency. Everything is about putting these products through as quickly as possible at the quality that they are aiming for. It's not about romance or anything other than that. This is very efficient, very high quality, but it's mass production.
And here what you have seen at the first station, it was just one bench.
Yes.
Where we do.
What you are seeing here is essentially time graphers. So they are individually regulating the movements, and then on the left they're basically checking them at different positions, and they go back and then they regulate a little bit until they get to the level that they want them to, and then they send them off.
But for example, now we will arrive at the station where we are working on the chronograph mechanism. And here we have 14 different
steps for one station.
And all this operation takes quite a long time. And to
Simple. The other movement was probably a time and date only, so it takes 9 steps. Then they have a chronograph. It takes 14 steps. It takes longer. It's slower. It's less of a conveyor belt. Still, to some extent, it is, but it takes more time and it needs more hands.
equilibrate a little bit the production flow, we have here 3 bench doing the same operation. And so with the quicker one and the longer one, we equilibrate to don't lose time and really optimize.
The amount of time this guy puts into thinking where the chairs need to be and we people need to be sitting to have the most efficient process is borderline insanity, but it's perfectly normal for a manufacturing or production engineer to be thinking about those kind of things, because this is where you save your money.
The timing for the complete process. Of course, at the end, when we are talking, we will pass through, you see here the chronometry, where at the end of the process of assembly, we do all the...
If you're looking at this and you're thinking, wow, this is amazing for watches, it is, but this is no different than pretty much any other mass production process. Whether you're making a car or you're making a watch or you are packing boxes for Amazon, you are worried essentially about 2 things that drive your cost. The one is your minutes per thing, so minutes per movement. How much time does it take from the time you start till it comes out as a finished product at the end? Because of course you have the components in between that costs money, the components and the electricity, but the efficiency that you can fetch in the time that the thing doesn't stand still, the machine doesn't stand still, that these processes have been so standardized that you can work on as many movements as possible as an individual throughout the day. That is going to bring down your salary cost, it's going to bring down your production time, and that means your overall cost is going to be lower. The other thing that he cares about is error rates. And that's the same with cars. How long does it take to build a plane? How long does it take to build a car? How long does it take to build a movement? That's the one piece. And then how accurate do you need it to be? Are you happy with 0% errors? Then you're going to have to compromise on your minutes. Or do you want 50% error rates? If you want 50% error rates, then you can fly the movements through faster, and that's the trade-off. Here, they're basically saying we want a combination. We want really, really, really low error rates. They're probably aiming for like 1 or 2%, potentially lower on some components. And then they want to get through and say, this is the total number of hours it takes to make a time and date movement. And that's the metric he's looking at all the time.
And this is prepared on the automatic line. And then it comes here to add the perpetual calendar modules.
So this is the room for the complicated stuff. A lot of the stuff is still done on the manufacturing lines that you saw before, but when you get to the more complicated movements, there's less that can be standardized, there's less that can be automated, and it's also a little bit more complex. So you're giving this to more hands. So the more expensive movements, the perpetual calendars, the Ratraprant, moon phase, whatever, flyback thingy-bobs, they are going to be in this room because they are harder to do from an automation perspective. So they need more hands and they need more skilled hands. So you're going to see people in here that are more skilled watchmakers and more experienced watchmakers that are working with the more intricate movements with more components and more sort of fiddly hand stuff.
And even the free sprung balance too.
And of course, that's also part of why these movements get more expensive, because, you know, individually are the components that much more expensive. Yes, they're more components, does cost a little bit more money, but the time it takes to put them together is also really a big driver of the cost, because they're just spending more time not moving through the line. So your hours or minutes per movement is significantly higher on a complicated movement than it would be on a standard time only or time and date.
When you consider that the timing to assemble a B19 versus a B01 could be 3 or 4 times
more.
Really?
Wow. Okay. Okay. So this is a room of technicians that might be a little bit more trained as like watchmakers here. So
absolutely less operational.
The thing I really like about this less trained or more trained, a lot of those people are just operators. They're not doing the most exciting watchmaker stuff. With the people in this room, this is where you want to get to, and eventually you want to get to the point where you're making the movements, because as you are further down the line, you are just, you know, a cog in putting stuff in. This is where you get to sort of flex your watchmaking muscle to a larger extent. But it's one of the downsides of these mass production companies, because for a lot of the employees that, you know, love watchmaking and are interested, their job is fairly repetitive and fairly standard and is not as romantic as you would probably like it to be.
Arriving finally at the end of the process, here we are in the T2 workshop, meaning the casing where the movement goes into the case and become waterproof. Absolutely. Here you can see we develop for any new development.
Couple of things to take note of here. The one thing is the guy was working with a little bit of compressed air on the watch head there. That's to remove dust and those kind of things. What you also can see on Dirdi is his beautiful little blue plastic socks he's wearing. Those are the things he's been forced to put on, and also the lab coat. Why? It's essentially just to make sure that dust doesn't get into the environment. This is something that most watchmakers are going to care a lot about, because dust, you don't want it on your dial. You don't want it inside the case. One, it can hurt the movement, but it can also give visual imperfections that, the more particular of you guys are going to notice when you see there's a little dust fleck somewhere, and that's when sort of the environment has been contaminated in some way. It isn't quite pharmaceuticals. Pharmaceuticals, you won't be walking in with your own shoes at all. You'll have to probably derobe and go fully into a hazmat or some version of it and wash down. But for the context of watchmaking, this is pretty typical. Cheaper brands are not doing this. They're just using it in a broader facility, and they're casing in a regular room. But the ones that can afford it and the ones that invest in it, you've probably got a pressurized room, got all sorts of sort of controls to make sure that the areas where they're working with open cases and open movements, that dust doesn't get in there.
Perfect setting, in particular for the very delicate operation, which is the ends setting.
So you'll stamp that down so you have all those tools there.
And then we keep it ready to use for the new series.
Mm-hmm.
And
another thing I've really noticed, there's a lot of new machines in this room. I've been in quite a few factories, and some of them are, let's just say, a bit of a hodgepodge of new machines, old machines, recycled machines, and used machines. This is pretty much everything they're showing here is up to spec, and some of the newest stuff you've got out there.
Sure.
We continue to do with the casing, where we put the movement with the dials and the hands inside the case.
We didn't see dial production either. Like I said, nothing talked about bracelets and the cases. Those two CNC machines can't make 200,000 heads, not if they're doing all the other stuff as well. And here, dials, we haven't covered dials at all. Could they be doing that somewhere else? Probably. My guess is they are buying the dials from somebody else, and somebody else is also doing the application. Could be in-house, some do it in-house, but again, it's a place where you have the flexibility to buy what you need instead of spending money on actually having the capability in-house.
And then from that, we start all the controls for water resistancy here.
And again, more testing. So they tested the prototype. They tested it after the phase when it's been through the initial manufacturing process where it's still a brass plate for the movement. And then they tested it once it gets past the finishing and comes back from the producers or the external suppliers. And now they're testing it again for different things. But again, it's a testing phase. It's more time. It's more investment in testing and quality assurance.
So Daniel, it's been a long day. I put you through the paces, but thank you so much for opening the doors to Breitling. Coming here, I've done a lot of manufacturer visits, but I can recognize the transparency of showing every single process, and I greatly appreciate it. I know people at home that want to.
Teddy's of showing appreciation for recognizing the transparency and showing every single step of the process. That's partially true. There's no obfuscation here, but to be clear, what we saw was a manufacturing process where a large part of it is done by Breitling, but there's also very clear, like I've said all along, and it's not a bad thing, they use external suppliers to do some things. So in the case of the prototyping, they have people that do part of the parts. They don't do all the parts themselves. They don't build all the parts necessarily. Some of them are bought. Barrels come from somewhere else, and so do individual components from the movement. Then you've got the two CNC machines that are not going to be pumping out 200,000 watch heads and 200,000 bracelets a year or 150,000. You just can't get those numbers with those two machines. Those machines were largely probably prototype machines and building some numbers of cases. But my guess is, and I don't think Breitling has a factory somewhere else, the cases and the heads in mass production are coming from somewhere else. And don't assume it's China. I would actually assume it's somebody in Switzerland or it's somebody in Thailand, because there are a couple of factories in Thailand that do that really, really well and that are much better than the Chinese. Then they also do it for the balance wheel. They said very clearly they want the know-how to make balance wheels in-house, which makes good sense, but they were also open about the fact that the mass production of the balance wheels is probably being done by somebody else. They do a small number themselves, but then somebody externally is building the balance wheels for them to spec. That's at least the way I interpreted it. Then also they were very honest about the fact, it was a side comment, but somebody else is doing the galvanizing of the movements and the plates, and somebody else is doing the finishing. And once that's done from an external provider, then it comes back to Breitling. So there's a ton of steps where somebody else is doing something or is supplying something. This idea that everything gets done in one building is untrue. And Breitling is not pretending that it is. But just for context, for those of you that have an idea of what's actually going on, it is a collaboration. That's the point I've been trying to drive for the last couple of videos. Another thing that's also really interesting for me to sort of point out, this is not romantic. This is mass production. This is how mass production looks in pretty much any of those factories of those $5,000, $6,000, $7,000, $8,000 companies. And there's very few hands that go through it. It's machines where they can get a machine to do it. The machine is going to be more efficient, it's going to be faster, and over time it's going to have a higher return on investment than the time it's spent on people's hands. It's only on the hardest, most difficult things where the machine can't do it. It's not for romantic reasons that they give the perpetual calendar to a person. It's because the machine can't do it. If the machine could do it, they would kick those people out of the door and they would have the machine do it. I have no doubt about that in my mind. It also says to me that this completely confirms what I've been thinking about Breitling. George Kern has done a lot of things. He's made some good products, but what they've done here, and you can see pretty much all the equipment is brand new, almost everywhere. This has been an investment in getting a really high-end, very efficient, very quality-orientated, and very speed-orientated production. Now, the people behind this know what they're doing, and they've thought out every single layout of these productions. And that is probably saving them a whole lot of money and making them really, really efficient. Typical private equity, I would say, compared to the companies I've been at, the ones at similar sizes look kind of the same. Some might have a little bit older machines, but not much. The smaller companies, they're not going to have this level of newness and process efficiency. If you go to a $1,500 watchmaker or $1,000 watchmaker, they're going to have elements of this, but then there's also going to be some shortcuts. Also, quality control. If there's one thing you take away from this video, then the thing you're paying for at $4,000, $5,000, $6,000, $7,000, $8,000, which you're not getting at $1,000, is quality control. Every single step of the process, there's some sort of check, some sort of control. I guarantee you, some random brand that's selling a watch for $1,000, they get a movement from Sellita. They are not pulling the barrel out and checking if the barrel and the mainspring inside works to the specifications they want. Obviously, they're assuming that Sellita have done it, but there are other things in terms of quality, cleanness, accuracy, all those kind of things. Those are the things that you're skimping on at $1,000, and you think, oh, I don't want to pay. It doesn't make the watch different. It does. The time you spend on just having the guy sit with that hammer, knock the hammer, and it hits the head to see if it works, that is a step they are not doing at a $500 or $600 watch maker. Maybe Citizen, maybe Seiko, maybe Casio, but the smaller independents, they don't have that level of quality control and product development assurance. That's much more, we build a case, build a thing, we put it in, we check it for accuracy, poof, off you go. And that's part of what you pay for. And if you look at how many steps there are, it's ridiculously expensive, the amount of time it takes where nothing is happening other than checking. That slows down production, that's costing them money, and that's what part of what drives up the cost. Part of what drives up the cost is also the name Breitling and the brand behind it, but there is value being added that is quite clearly reflected in this video. Last but not least, my biggest reflection in all of this, I said in a video about the market the other day that what brands should be doing right now is talking about value and how they're creating value and not about sort of luxury. And George Kern has said the same, the brands that can't communicate that they are value offering are going to have tough time in the market as it's going to be over the next couple of years or months or years. And this video is very timely because what is this if not a way to try and communicate value? There's a reason Teddy and Britt have been off to this site and they released the videos more or less at the same time. And that's because Breitling have an interest in communicating not that they are luxury, but they are high quality and you're getting a lot of value for your money. That's what they're leaning into. They're not leaning into BS storytelling as much as some other brands are doing. They're opening the doors and saying, this is what we do and this is why it's good. And their hope is that it's going to resonate with people and say, okay, they make value for money. 6,000 is not unfair for a Breitling top time or whatever. And it's pretty good marketing. So that was all I had for this time around. A little bit of a different kind of approach. I hope you enjoyed it. What are your thoughts in terms of the production processes? What do you think about Breitling in general? Also, what do you think about the way Breitling has used this as a marketing approach? I think it's kind of cool, and they opened the doors. And yes, Teddy gets some views on it. That's fine. But yeah, let me know what you think. Like, subscribe. Cheers.